So I think that, when we think about offshore wind in Australia, we naturally go to fixed bottom offshore wind. That's what we've been discussing in Gippsland because it's suitable to it. And I think that's right. I think that, as an emerging market, Australia should be looking at the more established and, to be honest, cheaper technologies. But there are areas in Australia, like in Hunter and Illawarra, where floating offshore wind is the only option. I'm Billy Mullin. I'm one of the offshore wind leads for Aurecon. And before that, I was back in the UK working as a developer on fixed and floating offshore wind, but my specialty was in floating design.
Could you give me an overview of floating offshore winds and how it works and what are its benefits?
Floating offshore wind is really aimed at harnessing opportunities that fixed bottom can't reach. About 80% of available seabed that's suitable for offshore winds can only be harnessed really through floating offshore wind. And it works by taking a lot of the inspiration that we've had from oil and gas in terms of semi-submersible platforms, moorings and anchors. The dynamic inter-array cables are quite similar to dynamic risers. So it's taking that inspiration and trying to make it clean energy. So some of the benefits include, like, if you talk to people like me who work or have worked, or even proponents of just generally of floating offshore wind, we'll talk a lot about the environmental impacts compared to fixed bottom offshore wind. And what we really mean by that is the impacts on the seabed and to marine mammals through noise during construction.
What are the biggest challenges in developing floating offshore wind projects?
Well, I suppose the biggest challenge lies in its technological immaturity and therefore higher costs compared to fixed bottom offshore wind. But I think we need to put that in perspective. So the first fixed bottom offshore wind turbine was back in 1991. The first floating offshore wind turbine was only in 2007. And so when it comes to, say, capacity outlooks globally for 2030, we're expecting around 13 to 14 gigawatts of floating offshore wind, but that's only 5% of the global market share of offshore wind. When we get to 2035, that capacity is expected to increase to about 57 gigawatts, or roughly 17.5% of the market share. And whilst we don't know what the announced pipelines of development projects will be beyond that, it's expected that that market share will close between floating and fixed even further in the coming years. And that increase in capacity really universally, almost whatever industry or technology you look at, coincides with the falling in cost through learning rates.
So why are floating offshore wind projects so costly, and how can we keep those costs down in the long term?
I suppose it sort of goes back to what I said in terms of technological immaturity, and we just haven't had the time or the sort of industry agreement on what a floating offshore wind project should necessarily look like. There are also issues around electrical transmission. Whilst we've got a good idea for the inter-array cables within the project, in terms of having dynamic export cables, which are much larger, carrying much more power back to shore, those are also issues that need to be ironed out. There's also just costs associated with really deep water installation. The time it takes to install the turbines, to install the mooring and anchoring systems, and wire it all up so that it works, is more, and it's more costly. But we expect costs, as I say, in general to fall due to the standardization of the floating platforms, and also the learnings and the process efficiencies that should come from the additional capacity that we expect to see. I said, when capacity increases, costs do fall, and that you can look at almost any industry and see that link.
And my last question, how do you see offshore wind supply chains developing in Australia?
One thing to bear in mind is these projects, these large infrastructure projects, are absolutely massive, but the economic and environmental benefits of getting involved in it are huge as well. I think when it comes to the supply chain, two things really are needed: certainty and time. certainty in two fronts again. One, the individual, I suppose, links, if you will, of the supply chain need to be confident in the economic benefits that they'll reap as for being part of offshore wind in general, really. And the second part is they need certainty that it's happening. And obviously they need time to be able to respond to the market and to developers creating projects and state and local governments pushing them.